In this tutorial, we define and explore the properties of quadrilaterals with parallel sides using the Desmos geometry tools. A quadrilateral is a closed figure made up of 4 line segments. This is quadrilateral ABCD. When opposite sides of a quadrilateral are parallel, the quadrilateral is a parallelogram. This quadrilateral is a parallelogram. Opposite sides are parallel to each other. Each pair of opposite sides is part of a set of parallel lines. Because parallel lines are the same distance apart, the opposite sides of a parallelogram are congruent. The important thing to note is that the congruent opposite sides are a direct result of both sets of sides being parallel. The opposite sides of a parallelogram are transversals to the other pair of parallel lines. This means that opposite angles are congruent and adjacent angles are supplementary. In this quadrilateral, angles A and C are congruent, and angles B and D are congruent. Also, angles A and B are supplementary. This also applies to these pairs of angles, B and C and D and A. Now we can look at special parallelograms. When all 4 sides of a parallelogram are congruent, it is a rhombus. This parallelogram is a rhombus. All 4 sides have equal length. Pairs of angles are congruent. When the angles of a parallelogram are right angles, the quadrilateral is a rectangle. This parallelogram is a rectangle. Notice the square corners. Opposite sides are congruent. When a rectangle has congruent sides, it is a square. With a square, all sides are congruent, as are all angles. Finally, when a quadrilateral has only one pair of parallel sides, it is a trapezoid. For this quadrilateral, sides CD and AB are parallel. This means that adjacent angles A and D and B and C are supplementary. This table summarizes the different quadrilaterals we've examined based on the number of pairs of parallel sides. On the left, you see that 2 pairs of parallel sides result in a parallelogram. Within the set of parallelograms are rhombuses, rectangles, and squares, depending on the number of congruent sides and angles. On the right are quadrilaterals with only one pair of parallel sides, which results in trapezoids. Let's explore quadrilaterals using the Desmos geometry tools. We'll be constructing quadrilaterals by first creating a framework of parallel lines. Then we'll use line segments to construct the parallelogram. Start by clicking on the Line tool. Draw a horizontal line on screen like the one shown here. Next, from the side menu, click on More Tools. Select Parallel Line. Click on the line you created and then click above the line to create the parallel line. Go back to the Line tool and construct a line connecting the 2 points shown. Click on the Parallel Line option again and create a parallel line like the one shown here. Finally, use the Point tool to construct the 4th point that defines the parallelogram. Click on any of the points to resize the parallelogram. Notice that opposite sides of the parallelogram remain parallel. Now hide the parallel lines. Highlight each of the lines and click on the Hide option on the side menu. Your screen should now show the 4 vertices of the parallelogram. Use the Line Segment tool to connect these points as shown. Label the points as shown. Then measure all 4 angles. Finally, measure all 4 sides of the parallelogram. Can you confirm the following properties of parallelograms? Are the opposite sides congruent? Are the opposite angles congruent? Are adjacent angles supplementary? Create different parallelograms and confirm the properties. Next, construct a rhombus. Recall, this is a parallelogram with 4 congruent sides. Next, construct a rectangle. This is a parallelogram with 4 right angles. Finally, construct a square, which has 4 congruent sides and 4 right angles. Now let's construct a trapezoid. For this, we just need 1 pair of parallel lines. Use the line tool to create 2 horizontal parallel lines. Use the point tool to add a second point on the parallel line. Hide the parallel lines, leaving the 4 points that define the trapezoid. Connect these points with line segments. Label the vertices. Measure the angles. Measure the side lengths. Try to get your trapezoid to look like this. Can you confirm the following properties of trapezoids? Only 1 pair of lines is parallel. Adjacent angles along the parallel lines are supplementary. Explore different configurations for the trapezoid. Finally, find the configuration that turns a trapezoid into a parallelogram.